go over proportional and non-proportional relationships. So we're going to start with proportional relationships and what that means. The definition is a proportional relationship is a relationship, can't spell, oh my goodness, relationship, sorry guys, a relationship where there is a constant ratio between the x and y values. X and y values. In other words, you'll see where y divided by x is going to be a constant value, and they use k to represent that constant value. On a graph, the criteria for a relationship to be proportional is it must be linear, which means it must be a straight line, and contain or include the point 0, 0. Or you've heard us say it has to go through the origin. So it has to be a straight line that goes through the origin. So if I was looking at a graph, it has to start at the origin and be a straight line. Or if you're looking at all 4 quadrants, it could go this way as long as it goes through the center, or this way. And it has to include the point 0, 0 in a graph and be a straight line. When you're looking at a table to determine if a table is proportional, if you see the point 0, 0, you'll know that it is proportional. So in a table, it could include the point 0, 0. If 0, 0 is not included in the table, one way to check to see if it is proportional is to cross multiply. If the cross products are equal, then the table is proportional. So if you look right here, 5 times, I'm going to cross multiply these two. 5 times 4 is 20, and 20 times 1 is 20. So these cross products right here and here are both equal, so that is an indication or a criteria that means that it is proportional. You could have checked these two cross products. 20 times 8 is 160. 4 times 40 is 160. The other way to determine if a table is proportional is to check the ratio of the y divided by the x. It must be constant. So if I take this y of 1 over the x value is 5, 1 over 5, all of the ratios in that table must reduce to 1/5. So I'm going to try 4 over 20. That also simplifies to 1/5. 8 over 40 simplifies to 1/5. And then 9 over 45 also is going to simplify to 1/5. So this has a constant. The ratio between the x and y values is constant. And in this case, k would equal 1/5. So yes, this is proportional because either you're checking the cross products to be equal or you're checking that the ratio between the y and x values is constant. So looking at this one, I'm going to start. The easiest way is probably just to check your cross products. Again, because I don't see a 0, 0 in the table, but that doesn't mean would not be included in the graph of this table. It's just not shown on the table. So I'm going to check the cross products. Well, 1 times 24 is 24, and then 6 times 4 is also 24. So these cross products are equal, so that would indicate that it's proportional. If I checked the ratio of the y to x values, 6 over 1, I'm going to do y over x is 6. 24 divided by 4 is 6. 30, take this one, 30 over 5 is 6. And 96 divided by 16 is also 6. So this has a constant ratio of 6. So yes, this is a proportional situation. When you look at an equation to tell whether an equation is proportional, it's going to be in the form y equals kx, where k is that constant ratio. And there's no addition or subtraction after that. It's just a one-step equation is how I like to include it. One-step equation does not include addition or subtraction after it. So examples would be like y equals 1/5 x or y equals 6x. Those are one-step equations. The y-intercept is 0, 0, so you don't have plus or minus a number after that. It's just one step. So a real-world example of a proportional situation would be something like I am depositing $50 a month in my bank. And you would probably need to include that I opened a bank account with $0 in it and am depositing $50 a month in my bank. So I opened it with 0. I opened an account with $0. And then you're going to start depositing $50 a month. So the equation would just be y equals 50x. You don't have an initial value in it to begin with. Okay, I'm going to stop the video, and then the next video I'm going to talk about non-proportional situations.